Welcome friends, in this one I'm going to show you how to find the following. The directional derivative of f of xy equals x squared y cubed minus 4y in the direction of this vector here at the point 2 comma negative 1 in the direction of the vector 2 comma 5. So it's a directional derivative question. You just need to compute all the ingredients as follows. You need the gradient vector, you need the unit vector in the direction of that vector, and then at the end you dot those, and then that gives you the value of the directional derivative. That's the logic pretty much. Alright, so let's go through the process. So first I'm going to find the gradient vector here. So the gradient of f, again, it's like a little upside down triangle, but this gets the idea across anyway. So let's find the directional derivative. So what you have to do is you have to differentiate the function with respect to x, that becomes the first component, and then the derivative with respect to y becomes the second component, as you might recall. So differentiate this with respect to x. With respect to x, x squared differentiates to 2x. This y cubed is like a constant, it doesn't change, and the negative 4y, again, is like a constant, so basically that derivative with respect to x is 0, it just goes away. Okay, 4y with respect to x doesn't change. Alright, then you look at the y. So with respect to y, this is by the power rule now, you're going to bring the 3 down, and it's going to be 3 minus 1, which is going to give you a 2, but the x squared gets copied, so it's 3x squared and then y to the second. And then you differentiate the second term with respect to y, which is just negative 4. Alright, so now you have your directional derivative at a particular point xy. You just have to evaluate it at this specific point 2 comma negative 1 now. So you plug that in and evaluate. It's a bit of a step. Let's work through it. Alright, so let's evaluate. So I'm going to evaluate at the point 2 comma negative 1. Alright, so you have to be careful here. So you're going to have 2 times the value of x, be careful, it's 2, times the value of y, which is negative 1. Now be careful again because it's cubed, so it's going to, it's going to stay negative. And for the second one, it's going to be 3 times 2 squared times negative 1 squared minus 4. So plugging in, that's PEMDAS, all of this stuff. Alright, so you're going to have 2 times negative 1, because it's negative 1 cubed, which is negative 1. And then here you're going to have, let's see, 3 times 4 times positive 1 from squaring negative 1 minus 4. Then you continue with this process. So it's going to give you now negative 4. 2 times negative 1 is negative 4. And it's going to be 3 times 4, which is 12. 12 minus 4 is 8. So we end up here with negative 4 comma 8. This is the value of the gradient at the point 2 comma negative 1. Negative 4, 8. Now let's find the unit vector in the direction of that same vector given. So you're going to do basically u is v divided by the magnitude of v. So you're going to have, let's see here, 2 comma 5. All right, divide by the magnitude of that. So it's going to be by the Pythagorean theorem, basically 2 squared, which is 4, 5 squared, which is 25 this way. Then you have 2 comma 5, simple. All right, in the bottom you're going to have the root of 29. Like this. So 2 comma 5 over the root of 29. That's our unit vector and the direction of that vector. Now we just have to dot the gradient at 2 comma negative 1 with this quantity here to find the directional derivative. Alright, so I'm going to do that over here. We have room. I'm going to use this notation. So the directional derivative, say in the direction of u, like this. Okay, directional derivative of f, right, in the direction of u, given by that. So it's going to be the following then, and we're doing it at a point, remember, so 2 comma negative 1, so that's the vector negative 4, 8, okay, and you're going to dot this with this vector here that looks like the following, okay, so 2 comma 5, okay, divided by, see, the square root of 29. Now we just have to work through this dot product, that's all it is. All right, let me move over this way. So the root of 29, you can just flow that out front this way, okay? The root of 29. All right, that's out here. And then what's left over within the brackets will be the rest. You just do the dot product between the vectors. So you're going to have negative 4 times 2 is going to be negative 8. And then you're going to do 8 times 5, which is going to be a positive 40 here, okay? So I just did the dot product. And then you work through that. So it's going to be basically 32 over the root of 29, and this pretty much then is the answer. It's just a number, it tells you the rate of change of this function this function right here. So 32 of the root of 29 is the rate of change of this function at that point in the direction of that vector. That's what the 32 over the square root of 29 means. But that's it. So I hope it's been helpful, friends. Please leave a like, please subscribe. Thanks so much for watching. Please leave some comments, ideas for new videos. I like those. I'll see you in another one. Let me move aside, make sure you can see everything. There you go.